Okay, so 2 weeks ago you learned about setbang. Setbang is a special form, right? Because its first argument, which is not quoted, has to be the name of a variable. Right? So that first argument is not evaluated, even though there isn't a quotation sign in front of it. Setcar and setcooter are ordinary procedures. Their arguments are evaluated. And they are because we have to be able to say things like this. Setcar could it or node to something. So that expression, whose value is a pair, that's evaluated. And the second argument, of course, is evaluated also. So it's a plain ordinary procedure. The exclamation point doesn't mean special form. It means mutator. Right? So it's a warning that you're not doing functional programming. And again, it's not the scheme system doesn't enforce using exclamation points for mutators. It's just a convention that you will do well to follow. Okay. So there's a relationship, though, between setbang and setcar setcooter. Namely, both of them make your program non-functional, because in both cases, the result of calling a procedure may depend on the previous history of the computation. So it looks at state, so it's not functional. And also, we're going to learn that if we had either one of them in our language, we could use it to implement the other one. So given setbang, the way we could implement setcar and setcooter is, remember way back in chapter 1, they said we could define pairs using lambda. And they did what you later learned is message passing. Right? So it was defined cons AB to be lambda of message, con EQ message quote A, EQ message quote car A, EQ message quote cooter B. Well, we can add to that EQ message quote set car bang, then set bang A to the new value, right? So we can use a message passing implementation of pairs and give it setcar and setcooter as messages. In the other direction, when we look at the metacircular evaluator, the scheme interpreter written in Scheme that comes up in chapter 4 pretty soon, we will see that environments, the things you learned about last week, are represented in the evaluator as list structure. And so if the user of metacircular scheme uses the setbang special form, we end up setcarring or setcooting, I guess, a piece of a frame in the environment. Okay? Okay. So let me get back to this question of how do you know whether you're sharing values or not? And in the example with A and B down here, we said that A and B are sharing memory. So if we modify B, it changes A also. And we said that H and J are not sharing memory. So how do we find what? So we have to make a distinction between two different meanings of equality that didn't used to matter. There's the kind of equality that means has the same value. If you print them both out, they both look the same. That's the one we've been using up to now, and it's what the procedure equal, EQUAL question mark, implements. There's also, are these the very same thing in memory, the very same pair, or the very same whatever? And the name for that is EQ. So if I say, here's A, here's B, equal B, coulter of A. Is that true? Yes, it's true, because coulter A is foo Z and B is foo Z. I can also say EQ B coulter A. That's also true, and it's true because A and B share pairs. So coulter A is the exact same pair as B. Whereas H and J, so here's H, here's J. Oh, well, they're not the same at all. Yeah, let's make a new one. Define X, list A, B, C. I should have said sentence. All right, never mind. Define Y to be but last of X. So here's Y. So equal Y but last of X. It's true. EQ Y but last of X is false. Because every time I call but last of X, it makes a new copy. So this but last of X is a different set of pairs from Y, even though they print the same. They both print AB. Okay, questions about EQ versus equality? Yes. Didn't they tell us back in chapter 2 that EQ is for symbols and equal is for lists? Well, yes, they did tell you that. But they said it with their fingers crossed. It was a simplification. It's a rule in Scheme, as in basically every Lisp system since the beginning of time, that there's only ever one copy of a particular symbol. Different from strings, different from numbers. We're talking about symbols. There's only ever one copy. So when you type a symbol into the interpreter, what the interpreter is doing behind the scenes is saying, oh, a symbol. Have I seen this symbol before? And it looks in a collection of all the symbols it's ever seen before. Yes, I have. Let me return a pointer to that same data structure. So when you type foo and then you type foo again, those two are always EQ. Now, they're also equal. But now you know the truth about EQ, which is it's true when two things are the same place in memory, the very same identical things. So we call that identity versus equality. EQ says are the two things identical. Questions about that? There are all kinds of questions you could ask. What about numbers? What about procedures? Yeah? EQV you want to know about? You're asking the wrong person. I have never in my life found a use for EQV. EQV is, the attempt in EQV is ignoring implementation. Are these as the same as things can be? And so it's kind of a halfway point between equal and EQ. The problem with EQV is that really implementing it correctly is awfully hard and slow. Whereas EQ is constant time, right? Equal for lists is theta of the length of the list, right? Because you have to go down, coutering down, seeing whether all the elements are the same. EQ for two lists take constant time because you just have to look at the first pair of each one and say, are they in the same place? So you're looking at pointers to things, those of you who've studied pointers. If not, you'll get it next semester. And that's just a constant time operation. So EQ is really, really fast. Equal is reasonably straightforward, but theta n, and EQV is supposed to be somewhere in between. The trouble is, knowing whether two things are mathematically the same is very tricky. So what should the answer be to this? What should the answer be? Are they the same or not? Well, actually, what I meant to say was EQV, so let me go back and do that. Oops. Hey. Oh. Let's see what STK does. STK says false. They're not the same. Mathematically, it's the same function, right? They have the same input-output behavior, which is all we care about. Now, if these things had local variables, right? So if I had said, let count be 0, lambda of nothing, set bank count plus count 1, blah, 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 twice, then EQV should return false. So in order to know whether two functions are the same function or not, you have to do some very, very careful, complicated, I'm not sure if it's even theoretically possible analysis. Jordy, you took 170. Is it theoretically possible to see if two functions are the same from the out? I don't know. Yeah. So EQV is always kind of a compromise between what it should be and what's possible. And so it's kind of messy and ugly, and I've never found a good use for it. The other equality tester is the equal sign. And that one is supposed to be true if the numbers are numerically equal, even if they're represented differently. So we want equal the integer 3 and the floating point representation 3.0, those should be equal, and they are numerically equal. Whereas they're not EQ, and they're probably not even equal. Let's see. Now they are. Okay. But there are all these different complexities. By the way, it's not even guaranteed that this will be true. I think it will be in STK. But if I say, that's false. Small integers are EQ in STK. Bigger integers, bigger meaning more than 4 billion, aren't. And that's just an implementation detail. So you're not supposed to rely on EQ for numbers. You're supposed to use equal sign. Equal sign will be true for those numbers because it actually takes the trouble to look through the complicated data structure that a large integer requires. Okay, one more question? Yes? Define x like this? EQ x quote I. That will be true because the value of x is a symbol, the symbol I. Anytime two symbols print the same, they are EQ. A Lisp system will never make more than one copy of the same symbol, okay? For efficiency reasons, basically, storage efficiency.